Well, hi there, welcome to my latest video. Well, in this one I'm going to give a full-blown lesson on information and computer security. They're not exactly the same either. When you talk about information security, there's more consideration for keeping things secret, privacy, and also data integrity related to it. Which when people talk about computer security these days, they tend to only be thinking about antiviruses, which is way off of what they should be thinking about. But I'll go over that in a lot of detail. I'll cover the 5 principles, which I call tenets of security, and what they mean. And also, I will talk about Windows 11, right? I want to focus at the end of this video towards what Microsoft is trying to do, or at least giving the impression of doing, in coming up with the new restrictions that they're placing on security for Windows 11. And I'll get into that in some detail, believe me. I'll also be talking about encryption technology, and some of it I'll try to keep high level, but I'll try to cover the concepts deep enough to where you can at least follow what's going on. The entire presentation is based upon a presentation in PowerPoint, so hopefully you don't mind seeing a presentation like that, but that allows me to cover everything I want to cover and keep it to the level of depth that I think is important. Well, hopefully you get something out of this video, and if you do, you could at least consider subscribing to my channel and give me a little like here too. That would really help the channel progress to future videos, and maybe I'll turn this into a series if there's enough interest in it. So let's get started. So who cares about personal computer security? Well, like I say here right in the middle of the screen, much fewer than should. But in addition to that, you got to be careful of the so-called trusted security experts that everybody knows, because some of them are basing it upon 1 or 2 key attributes of security. One of the key ones that almost everybody, including major corporations, focus on today have to do with just anti-malware, worried about the viruses. That's a small problem, actually, when you really look at things. Going back years ago, there weren't a lot of malware that was a problem, and they still had a lot of issues. Hackers breaking into the networks, hackers breaking into your systems that are exposed to the network, and a lot of other problems that are much more pervasive and allows you to not only break computer security, but break into people's private stuff, corporate private stuff, and it has been known to take companies down because their stuff got exposed. So I'm going to talk about some of the basics to that, and we will see what happens. But be careful of those trusted experts, make sure that they should be trusted. Okay, the first thing I want to cover is somewhat boring, but it's what I refer to as the key areas before you can understand this. Matter of fact, I refer to this as the tenets of security. The first point will be covering those 5 security tenets, which are principles. Then I'll go into the user accounts, authorizations, and the access associated with those accounts. I'll talk about controlled network connectivity. I'll then go into encryption. This is primarily what number 4 is about. Where I'm spending most of the time on that, which is item C there, but B and C. But I also want to cover backups and storage because they play a role in security as well. And then finally, in the 5th section of this presentation, I'm going to talk about Windows 11 security. And this will be more of an open discussion area because, unfortunately, we don't know a lot about what Microsoft is really trying to do. A lot of it's being guessed at. But I have a pretty good idea what they're guessing at here. So we'll at least, that's my view. We'll discuss it. Okay, the 5 tenets of security. Now, if you ever take a security certification exam, I have the CISSP, which is a coveted information security credential to get. These 5 tenets of security are key to a lot of the areas. There are 10 areas associated with passing that test, and this represents 5 of them. When you get into the areas like number 5 there, non-repudiation, it gets very, very complicated. I'm going to just skim the surface tonight in talking about that when we get to that area. And actually, what does it mean, non-repudiation? Just to get you started on that, you do an online transaction. What prevents you from really denying it? Let's say if it wound up in a court of law. If there are controls in place, the company you're doing business with adheres to good security practices on those controls. If you try to deny that you did the transaction, it will not be an easy thing to do, quite honestly. But we'll talk about that more. The first one, identification, is you want to know who is trying to access the system. Anything in the system. To be able to log on to the system. That's what you mean when you say identification. Who are they? Then once they're in the system, the next thing is authorization. Authorization is what the users that do have permission to be in the system, what will they have access to? Now that's very important, and that's what we'll talk about even more with the administrative account. An administrator's account, and this is one of those things that a lot of even corporations and even government agencies, I'm afraid to say, they forget about that part because they don't really think that the administrators are a risk. Now, maybe the administrators they actually have working for them as administrators are being people you could probably trust. Hopefully you've done full background checks on them, and you have some level of cross-check on what they do, right? That they're not left with total control of everything. That's why you usually have multiple administrators to an account. But it is the most vulnerable part of it. If somebody runs in an administrative account, as I referred to when I was talking about malware, the system can be completely taken over. That's how malware gets into the system. The average person does not create a user account. They take their Windows installation, whether it's a PC they bought or a PC they've just installed Windows on, and they go ahead and they let them run as administrator, browse the internet, access their email, click on bad links. All of that will have the potential of completely destroying your system. Because if it is a bad link to a malware, that malware will have access to everything in the system. I mean, that's how all of the issues in terms of getting your system hijacked and held ransom with ransomware. Because once they get into the system, they get down to the lowest ends of it, they can go ahead while you're not even aware of it and encrypt your entire hard drive. And they have the key to that encryption, you don't. And then, of course, they offer to sell it to you. And it shocks me how many people actually do pay the ransom. I know people personally that have paid the ransom. Small companies, a lot of them have paid the ransom. They have no choice because they don't have legitimate backups, which we'll talk about later. Then confidentiality. Now we start getting into more of the real cryptographic controls that a system could have, if enabled. So confidentiality, what prevents somebody on the system from seeing somebody else's data? Well, obviously, if you have user accounts in Windows, one user tends to not be able to see the files from another user unless that person has given permission to those files, or they put them in an area that is not an area they can lock down. Certain directories within the system, you really don't have full control to set up those permissions. Therefore, if you put files there, then any user in the system potentially could see it. That also holds true if there's, let's say, a USB type drive connected to it, and you put files out there. The other users, potentially, if you don't have it locked down with authorization controls, they can get to it. So that's confidentiality, just keeping people from seeing things that they shouldn't see. Now, integrity. Integrity is the prevention of modifications to the information. You could imagine what could happen if somebody got in and modified the information so that you think you're going to a bank, but they changed your link to go to a fake website that looks like your bank. Now, they will still contact your bank for you. So they'll have in the system itself, the application will go ahead and be a proxy to your real bank, but they'll capture everything in between, including all your passwords, all your account information, and everything else. So that's integrity. You want to prevent that, and only cryptographic controls, or encryption, as we'll talk about in a little bit, can do that. And then finally, the one that I already talked about, the non-repudiation, which is really completely immersed into encryption technologies to do it right, and I'll be covering some of those later. Now, here are some basic things that I suggest when it deals with your account authorizations and basic access. First of all, I want to point out that Windows and Unix are very different in this area. Now, I say Unix, but the most common form of Unix that people are aware of today is Linux. So almost everybody has heard about Linux. Not anywhere near a large number are using it, unfortunately. Because you can lock down a system like Linux. It actually, when you go install Linux, it makes you create the separate accounts. It won't let you easily run as an administrator. You would have to intentionally try to violate the basic controls that they're trying to implement when you're installing it. Now, a lot of people do that. That's something that they would have to intentionally try to do, whereas in Windows, they don't have to intentionally. By default, you don't create accounts. You are an administrator, and you have to know how to create accounts. Now, I did make a video about that, so I'm not going to go into the details on this right here. If people want to see more on how to do some of these things that I'm mentioning, I'll be glad to make follow-up videos. So if you want me to go ahead and make a new one, I'll be glad to do that if I get enough people interested in doing that. You should never browse the internet or read email, as I indicated before, if you're logged in as an administrator. I don't do that. I made a point in one of my other videos as well. When I log into the administrator account, there's a specific reason I'm doing that. As a matter of fact, I have a background to the screen on my administrator account that warns me that I am in fact as administrator, and I list the things not to do. So it reminds me. I'm a big believer in constantly reminding yourself of what you have to do. So eventually it'll become mental muscle memory, right? You'll have it ingrained in you, but it's a hard thing to do. All modern operating systems allow for user accounts. There was a time when Windows didn't, but they do now. They've done so since Windows NT, which was, the first real strong version of Windows that I felt comfortable with. And I actually installed Windows NT on my home computer systems when everybody else was running, Windows 3.1 or Windows 95 or Windows 98 or a few other of the Windows, variants that they created along the way. It was every year they were trying to make another one. As soon as Windows NT was available, I went right to it. Now it has deficiencies that they fixed with, later versions of Windows. And I'm glad that they did that, but you can do the user accounts going way back to then. So you do have them. Now, you also have the ability, believe it or not, with Windows 10, and I think even with Windows 7 for sure, it allows you to set up authorizations on files. You can set permissions on who can get to the files or directories so that you can lock them down even further than just Windows would do, because a different user shouldn't by default have a certain level of access. Maybe you don't want them to even read a file as opposed to read and write, which is a lot of times that's what the default, to just make it read only. You can also do, as I'll show later, you can encrypt files and you can encrypt directories. And that sort of feeds into what we're going to be talking about with Windows 11 as I get to that. And then finally, always use strong passwords. Now, passwords are a big problem. Someday in the future, maybe 50, 75 years from now, hopefully not 100, we won't have to have passwords. Think of it this way, and this scares people, but it shouldn't. How do you know who you're dealing with? At work, socially, whatever. I mean, you're a little more careful with people that you meet for the first time, maybe even the second time. But as you get to know them, you learn to build up trust with them. How do you know who they are? It's not having them recite a password to you, right? Hopefully not. Well, what they can do with AI, if they wanted to, they have to do some more research to get it working right. They could have the computer completely recognize you the way you would recognize another person. And not just by your visual representation, because there are quirks to that. And some people look too similar to another one, but it also can incorporate your voice pattern. And not just your frequency pattern of your voice, but also, the way you talk in general, the accent that you have, the mannerisms that you use, even hand gestures, that you might use. You can recognize that if you really wanted to put the research in and come up with an AI engine that was your authentication. And I think that's the way it's going to be sometime in the future. But you need to use strong passwords, and I'll talk about that a little bit more as we get into this. Controlling network connectivity. Now here is where you start getting into the weeds. And when I mean into the weeds, it's an old expression. It means down into a level of detail that a lot of people would find uncomfortable. For example, there's a lot of terminology here that can be quite confusing. For example, I start with the first one. Make sure you have a firewall between the internet and your, I should have said your, not your personal computer, to ensure IAC. IAC is an abbreviation for Integrity, Authorization, and Confidentiality of your network. Now this is generally if you have your own network, but it can apply to just having a single computer connected up to your internet router. A lot of people, that's the only way they run. They don't have multiple ones, although these days most of the ISPs, the internet service providers, the ones that you buy internet from or rent internet from, however you want to look at it, they provide a wireless router automatically. And that wireless router is there because everybody's got their phones. They want to connect up to higher speeds and using the data network that the cell phones default to, because sometimes there's a limit to how much of that you can have. If you go through your network at home, which is much faster and has more non-accounted for capability, then that's what you want to do. And I'll talk about that more as I get into some network diagram. So I can go further that if you have a home network, whether it's wired or wireless, believe it or not, most people today have only wireless. They wouldn't know that their router even is capable of connecting directly to with a network cable. It's not something that people want to fuss with. They don't want to go and deal with these cables, right? These network cables here, right? What we call an RJ45, which is this type of cable that is used for standard Ethernet on a computer, right? So most people don't even know that exists, let alone how to use it. So, that's just the way it is. If you do have one of your networks that is wired or wireless, doesn't really matter. The same consideration has to be in place. Make sure your firewall is the single point of entry into your network. It is possible, depending on your internet service provider and also how it was wired up by them. Less likely by them these days as by you. For example, you could go out and buy a little 1 gigabit, what we call a switch or a hub. If you go and buy for like, I saw them in Micro Center for like $7, a little 5-port hub, then they could connect the computer directly to their internet, and they can let the wireless router connect to one of the other ports on this little mini switch. And some people believe, and we're told that by some experts, that if you do that, chances are your ISP will dish out 2 different IP addresses to you. I think a lot of them stop that now, but I'm sure there are some that don't. And if you have 2 different IP addresses, it theoretically can speed up your throughput to the network, but it would not be worth it because now you have no firewall on one of them. If the one that's going through your wireless router, the wireless routers tend to be little mini firewalls, but the other one that's not going through that would not be protected at all. Be very careful about enabling external access into your network. And sometimes you'll get, even there was a game that my older son was trying to use when he used to live here, and he needed a specific set of ports. If you've heard an IP address where every computer has an address, well, imagine that being the block that you live on. Or no, let's look at it this way. Let's say that's your house, better analogy. So you have the address of your home, but how many entry points do you have into your home? Well, you have at least 2 doors. Most houses will have 2 doors, some will have more, and you have any number of windows. All of those are potential entry points into your home. Well, when it comes to a computer, the computer itself has an IP address, a distinct address assigned to it, usually by the router or by the internet service provider. Then each one of those addresses is broken down into a large number here, up to 65,535 different ports, different entry points into it. And the first 1,000 of those are what we call secure ports. Again, I'm not going to get too deep into that, but just imagine all of those. That's how hackers used to get into corporations, especially when they didn't have a firewall, because a lot of those ports were not protected. It's like leaving a window open on your house, at the side of your house, and not even realizing that. Anyway, that game required that you opened up a window. You opened up one of these ports so that it could communicate with this gaming server through that port and didn't have to go and get translated through the other ports, which would slow it down. Well, I was very careful in enabling that port. First of all, it could not have been one of the security ports. It could not be one of the first 1,000. It was up in the high reaches of the port range. The game recommended opening up 20,000 addresses. Well, I ran a scan on it to find out exactly what the game was using, and then I only restricted it to, it was only probably a couple of dozen ports that it actually needed. And as soon as that game was no longer being used, I turned all those ports off. You got to be very careful with that. If you call up your ISP, your internet service provider, and you have that situation, a lot of times, I don't know if they'll charge you or not, they'll go ahead and open up those ports for you, since today a lot of the ISPs have control of your router. They don't have control of mine here at the connection that I have. I'm the only one that has control to my router. Few home router products have strong firewall capabilities. When we say firewall capabilities, it's more than just blocking the ports and restricting the access from the outside. A real good firewall can do a lot of intelligence on what's connecting to it. So it has the ability to actually look for potential patterns of an attack, and it can tell a computer attack from a non-computer attack. There's logic built into the software of a real firewall that can do that. Plus, it has logging and alerting for you. So if you suddenly had a situation where it looked like it thought that it was being attacked, it could notify you. You give it your cell phone number, it can send you a text message, you give it your email, it can email you, sometimes doing both. So it has ways of alerting you to the situation. Hopefully you're listening to that. Hopefully you don't have your phone turned off. A lot of times, just like the example I gave you with the game, if you buy a packaged network addressable storage called a NAS, for example, the Buffalo devices I have, they do have that capability where you can set it up so you can access them from computers outside your network. And if you do that, you are placing a severe risk on your data and potentially your systems as well. If that particular NAS has bugs in its operating system, they tend to use more simplistic operating systems as well, so they don't necessarily have a lot of software backup to them. When I mean software backup, the ability to have code in there that can be a little more intelligent, but that's usually missing from it. Not always. Some of them are based upon a full-blown version of Linux. That's fine. A lot of times it's a stripped-down version, though. What that means is that they only put the modules active that they needed to get the function to work. Hopefully they didn't turn off all security. And the ones I've seen, they don't do that. But if you go ahead and enable some of this remote access into your network, all bets are off in terms of the security of your data. It's just gone. And then finally, I wanted to talk about authorization. Now, you notice I highlighted in blue certain words here in the presentation. Well, those go back to the first slide that talks about the 5 tenets of security. A tenet, again, a principle. So every time I've mentioned a particular tenet, I've highlighted it here so you see how it applies. Passwords allow you to control authorization primarily. That's the most important thing. But it can also, I could have just easily added to that the other two in terms of integrity and access control, because passwords apply to that as well. But authorization is the key one I wanted to point out here. Critical with your wireless access and network device passwords. What I mean by that is you don't just have computers on your network. You have network equipment, firewall potentially. You have, which is your router. It usually is an addressable device on your network that you log into. You also have, a switch that has some intelligence to it. It could be a managed switch, which means you can log into it. It could be a device that you have just to do maintenance on your system. Maybe the box that does the backups for you. Definitely your NAS devices, the network addressable storage. Every one of those is a network device that's on your network if you have a network that includes those things. And you need strong passwords on all of that. Let's talk about controlling network connectivity graphically here. So here's, the cloud is the internet. I'm doing it all pictorial-wise. In the box there, I have a firewall and I have a wireless router. I put a box around them because a lot of times they have both in one. So you get the wireless router and it also includes firewall capability in it. And they've been getting better, but the better devices are much more costly. So the ones that give you more advanced security features as a firewall, they could double, triple, quadruple the price of your wireless router. Some people worry more about whether it's Wi-Fi 6 or some other lower version of their Wi-Fi, but that's, to me, that's not as important as whether or not the security features are in it. So we have the firewall, the internet and the firewall. Let's say we have a network. So here's a wired network. I illustrated I have 3 desktop PCs and 1 laptop all connected up, which actually works out pretty good because the average wireless router that you would buy has like 5 ports on it. 1 port that you connect up to the internet and the other 4 that you can connect computers to. And plus it is wireless, so it has really any number of wireless devices you want to configure into it, but most of them limit themselves to just a 256 address range of addresses that can be dished out by your router. And some of those are being used by the hardwired devices that you have, and some are being used by the wireless devices. Plus the network devices themselves, like the router itself uses one of those. And there's a couple of reserved ones at both extremes that you can't use. So it's really only 254. It's not going to get into the weeds too much, but it's called a Class C or /24 division of network addressing. You can extend that if your router supports it, but it's one of those more complicated configurations that most people are not going to bother with. But usually that's more than enough to have 254 addresses to your home network. Small corporations might have an issue with that and have to be configured for a larger address space, but it's possible. So we got the wired one. This is the classic way you draw a network, a wired network. You draw it so that there's one long flat wire like this, and then all the devices connect to it. Then I have a bunch of wireless. In this particular example, a bunch of wireless devices. So I put Wi-Fi next to each one of them to indicate that. We have a couple of desktops, we have a couple of laptops, we have a couple of smartphones, and I even put in here an Alexa just to make it complete, right? So, you could see a large household having this type of configuration, probably more phones than anything else. I thought about that after I made it, but it's good enough to give it as a representative example. And then what I put down on the bottom here, I wanted to make sure I covered it. There are many, many different websites out there. This is just one of them that I just happened to find this morning when I said website, password checking website. I tried it. It seems reasonable. You type in a password. I would suggest, though, you don't type in the exact password on any of these sites that you use. But try to keep it the same length and the same number of special characters and numeric versus alphanumeric, capital versus lowercase. Try to make a password that's like your password and plug it into one of these websites and see what they tell you. This particular one tells you basically if there was what they call a brute force attack on your password, which is something I used to do. There are freeware tools that'll do this for you. So if somebody wanted to brute force attack and they had access to your encrypted password, it tells you how long it would take for them to crack it based upon the length and how many different types of characters, special, numeric, that you happen to have dispersed throughout that password. For example, the password that I have for my wireless network here, people laugh, but it takes forever for them to type it in because it is much, 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 much longer than the average wireless password that you would find out there. Okay, that's all I'll say about it. So this is an example of controlling your network connectivity. Now let's talk about information security. This is where we start getting into some of the meat of it. The storage and backups. I'm going to say a couple of things about this that I have listed here. First of all, be mindful of how you store your data. It surprises me, and I see videos from some really high-end content creators that have millions of subscribers and are probably making a lot of money. They're not as careful as I think they should be with how they store their videos, their sources, their videos itself, which leads me to believe they're not as careful about their passwords and not as careful about a lot of other things. You get an impression about people. When I used to do security reviews as a consultant, we would sit and question people that they didn't expect us to question. We would actually ask to interview the people in the clerical department, even the receptionists. Receptionists give you a lot of information on security. I can tell you that right now. They see who comes and goes. They see how security works. It's one of the ones that I tried. We couldn't always get to do it because sometimes the buyer, the company didn't want us to do that. They didn't see the value to it, but we always asked when I was doing security reviews. So be mindful of it. When I talk about how you store it, if you're putting it on USB sticks, even USB attached storage devices, where are you keeping this stuff? Are you just putting it on your desk in a drawer? I don't see them encrypting it. So I wonder about, what the controls are. Physical security is a prerequisite. I didn't cover that here in the basic information security tenets, but I mentioned there were 10 domains to become certified as a full-blown CISSP. One of them is physical security. You have to know how physical security is taken care of around your computer systems, and that includes not just the computers themselves, but all of the information that's going in and out of that computer. And to go and put it on a 4 terabyte external hard drive, and when you disconnect it from your PC, you figure it's safe. Well, where are you storing that? As one example. I won't name any of the content creators that I've seen do that, but it always makes me wonder how strong really is their security. So and I say here, placing them in multiple external hard drives may lead to you believing you have redundancy. And it is right. Redundancy is only one part of it. I run into that problem in my day job as well. They think just having a backup of something is all the security they have to worry about. But they're forgetting about the confidentiality part of it. If you make 3 copies of what's on your computer and you have all of your financial data on that computer and you don't have it encrypted, now there's 3 opportunities for somebody to get a hold of one of those backups that you have and get all that information. What if one of them goes bad on you? You can't access it anymore. What do you do with it? Do you take it and bring it into your workshop? Hopefully you have at least a drill and you run the drill through it a few times to destroy the platters? Do you do that? Well, that's required. That is actually required by certain regulations for certain industries that they do just that. My day job actually has a hard drive shredder where any kind of hard drive, any type of device, even if it's solid state, they put into this machine that basically crushes it and chops it up so that it's completely unusable. You basically come out with little pieces that are no bigger than a half a centimeter out of that. And usually that's more than enough to do it for you. That's very important and people don't think about that. And as I mentioned in the last bullet here, backups are a critical component of the integrity part of it. I should put that in blue. Information security, now we're getting into it. Methods of local encryption. Windows 10 comes with hard drive encryption capability, a tool called BitLocker. It used to be a separate product years ago you had to buy, and I guess they bought it out and now they included it. It's a nice tool. My work laptop has that on it. And before I can turn on, it comes up with a screen that asks me for a passphrase. And I have to be able to type the right correct passphrase into it before it'll boot up. And there is some count. I don't even know what mine is set to for my day job. They don't tell us that. But you can also, in addition to the BitLocker, you have the ability in Windows 10 to actually do file and folder encryption. And that's done built right into it, into the properties of your file system. These options in Windows, really, I give an example of how to turn them on. With Windows 10, right-click on an object. That could be either a file or a directory. Go into Properties, then Advanced, and then check the encrypt contents to secure data and hit OK, and it's done. Now, where does it store the keys if you don't have a hardware device on it? Well, that's where the problem is, because if you don't have a hardware device that can securely store the keys, like a TPM or equivalent, then it has to store them inside the PC itself, and it puts another level of encryption on top of that. But a hacker who has complete access to your system, given enough time, can reverse engineer all of that, because the data for unencrypting it is all on the PC, including the private keys, including the certificate. And we'll talk more about the certificates and the private keys in a little bit. But there is a tool then called certmanager.exe. You won't find an icon for it. You have to go down into the search bar of Windows 10 and type that in, certmgr. You don't have to do the exe. It will find it. You click on that, and what it does is it opens up a tool. I have a capture of one that I just did this afternoon. It allows you to do a lot of things with your certificates, because that's the way this file and folder encryption works. It creates a certificate to do this, and that certificate, which has the private keys as part of it, are stored in your computer, and it actually has under one of the options, I think under the action drop down, it has the ability to export it, which is highly recommended. If you don't have a hardware device and you lose that certificate on your computer, you won't be able to access that folder anymore. So let's say you had that certificate on the computer itself somehow got corrupted, you accidentally deleted it, whatever it is. So they recommend that you export it to another device, like a USB connected device, hard drive or USB memory stick, and then save it. But again, what is that for? That's for backup of the certificate. It does not account for the security of the certificate. Imagine if you lose that USB stick and it has your certificates on it. Right? You're wide open if somebody gets a hold of your drive. So that's one of the things that we'll talk about later, what a TPM helps you solve. So that's what we call local encryption. Now, protected sharing using encryption. Let's say you want to share a file with somebody. You want to make sure that if the file is captured along the way while it's being transmitted, whatever means you use, well, you can encrypt it. There are all sorts of freeware tools that are out there. As a matter of fact, some of the tools that you would normally use, like some of the zip utilities and Microsoft Word itself, although the Microsoft Word version of this is kind of weak, but the zip utilities, whether it's PKZip or 7-zip, whatever it is, they have the ability to encrypt the actual package set of files. And you have to have the passphrase in order to open it up at the other end. So it becomes what they call a shared secret, which at one time, that's the only way they did it, going back many years ago with encryption. The actual mathematical calculations that are done to encrypt something has been around a long, long time. But how you deal with the keys is the trick. You have no real encryption and no security based upon encryption unless you control the keys. Keys to the kingdom, right? A better one is called public-private key. And that is a concept where a pair of keys are generated, and it uses advanced mathematics. They have to be based to some degree upon prime numbers, which are very hard to calculate, in order for it to be the matching set of keys. And I'll show you what I mean by matching set in a little bit. And then the final thing is certificates. Now, certificates were created originally for trusted third parties. You use them all the time, whether you realize it or not. You go out to a site that has the S, like HTTPS, rather than just HTTP. Well, the site, by having the S on there, they're telling you, and there's a lot more to this. I'm oversimplifying this, I know. I just want to give you a real touch of it. They have gone through an approved certificate authority, and the certificate authorities then basically vouch for that website. So when you go to access it, your computer will either already have a certificate that says that site is good, or it'll go out to one of the known certificate authorities that are out there that everybody knows about and gets the certificate for that site. And what happens then, let's say you had accessed that site before, and now you're trying to access it again, and the certificate doesn't match. That'll happen sometimes just when the site has upgraded their server, they wind up changing their certificate. And if they do that, then it won't match, and now you have to, a pop-up comes up in Windows, and Linux too, that'll tell you that that's a risky thing to do, that site certificate doesn't match. You could still ignore that and proceed if you happen to know that they changed the certificate, but you have to really stop and think about it, whether or not that's what you want to do, okay? It gives you at least the opportunity to stop and evaluate, think, decide. What is the risk involved? Well, if you're doing something low risk, it doesn't matter. You're putting your credit cards out there, that's high risk, but it does matter. But also certificates are used, that concept is used, even what we just saw in terms of the Windows 10 Cert Manager. So it's really a data structure that has a lot of information in it about a particular computer, including the public key for that computer, which I didn't explain what public and private are yet, but I will. Let me show you how this works. This is a flow of the public/private key. Let's say you have two individuals. Now, they could be systems, they don't have to be people. So I'm calling them person one, person two. They want to send messages to each other back and forth securely. Now, they could share a key. The problem is that would be only somebody you really, really trust you would share a key with, because they could decrypt other messages on you that you're sending to somebody else. So you don't want that necessarily to happen. So the public-private solves that issue, and I'll show you how that works. So let's say person one wants to send a message. He has data. I'm calling his data number one. That's referring to person number one. And he has a private key. That's one of the two keys. That's the private one. There's also a public one. The only person or computer that should have that private key is person number one. That key should never be shared with somebody else. So anyway, they get fed the combination of the data and the private key. I won't go into the math on this. I'm oversimplifying it and just calling it encrypting it, which is going through a software utility that's going to merge them together and produce a encrypted message. Then it gets sent to the other person, number two. Now person number two has to decrypt it. And the way they do it is they have your encrypted data, which has just come to them on that dashed line, and they have your public key, which they may have gotten from a certificate that you passed to them, or you just shared the public key with them. There are utilities that you can add to your PC, for example, that would let every email use this concept. PGP, pretty good privacy. I don't know if that's called anymore, but that was a big seller for many years, because it basically, if you installed it on a computer, it created a public-private key for you, and it shared the public key with people that you do business with. So a person that you email to, it actually could turn your public key into a text message that would be attached to the message. So anyway, you get the message, you use the public key, feed it into a matching algorithm that you have that takes the message and the public key, blends them together cryptographically, and now comes out at the other end with the actual data message that was sent to you. Then we can go the other way, but now we're changing keys. You only have your private key. So when you see private key number two and data number two, that's stuff that belongs to person number two, with the private key not being shared with anybody else. They go into the encrypt engine, just like we saw with person one, gets sent across, and the same thing happens. But this time we use the public key of person number two to decrypt that message. That's how this works. It's actually at this high level, it's pretty simple and straightforward, and is the essence of most of the encryption that is used today. Now let's talk about Windows 11. I'll start off with being blunt. What Microsoft is trying to do, they might get a little upset at me if they hear this, I guess, but it doesn't matter. Even if they were a sponsor, I would say it. They're trying to add security. Let's put it this way. It's not really security. It is the image of security, almost like a false sense of security to the most part, by trying to force certain security features into your computer that are good to have. Don't get me wrong. They are good to have. But as you'll hear later, there were better ways of doing that. Or you've already heard earlier from me, there are better ways of doing it. And the cost being forcing many, if not most of the people out there to buy new systems, plain and simple. This requiring everyone to have a trusted platform module, which is just really a giant chip, and I'll show you a picture of it in a moment, is only a Band-Aid. Band-Aid in security parlance is something that gives the impression of doing something, but it really doesn't stop the bleeding. Nice big Band-Aid might look good, but it's not going to stop you from having serious complications from the wound, if you know what I mean. So what is a TPM? It is supposedly, I think they've been tested to some degree. I'm not sure to what degree. I know the ones that have been used years ago by the government to meet the Red Book security, I think the D level, I think the D level is the highest level. It went through tests like you wouldn't believe, and these were the dongle things I referred to. If you basically try to open up the chip, or you apply signals to it, you actually desolder the chip, if it gets beyond a certain temperature of being desoldered, they would actually destroy what's inside. I mean, so you can get quite extensive. They claim that some of that is in a TPM, but I'm not sure. I didn't do the scientific review of this, so I don't know to what degree it is. I did do the scientific review of some of the older devices before TPMs existed, and it was quite extensive. That's what the NSA was in the business of doing at one time, was validating things like that for highly top secret government organizations mostly. It's supposed to be a tamper-proof chip that securely stores private keys, which I've explained the importance of those, digital certificates, which is the entire data structure that has private keys in it, and public keys. This is marketing stuff. It enhances network security, protects digital identities, and ensures platform integrity. Well, in a way it does, but I refer to all of that as a security silver bullet. Everybody's always looking for the simple way of solving all your security problems. We refer to that, the insiders in information security, refer to that as the silver bullet, which doesn't exist. There is no silver bullet. Good security is hard work and takes real cost and takes real computer resources to do it. To mention that quickly, when I used to do security reviews, believe it or not, the biggest problem we ran into, and this is true, of all security. There are three components to security. There is organizational, or the people. There is your process, usually written procedures and other software written to enforce a procedure. And then there's technology. Something like the TPM is a technology solution to something. If you don't use it because you didn't put it in your procedures and you go ahead still and expose it, it's useless. When you break down the percentages of those three, I probably should have put a slide in there on that. Technology is only 20% of security. Process is 30%. The remaining 50% is people. If you choose to give your password out to just anybody, it's meaningless, completely meaningless. If you choose to let people who are offering free software support because they're trying to get started, I know somebody who did this, they're trying to get started in being small business. It happened to be following the things that the state likes in terms of who owns that business. And they reach out to you and say, we're willing to support your systems. You just have to give us remote access into it. And you go ahead and give them that remote access as an administrator? Come on. There is no security then. You would have had to, as the person in charge of that security, understand that you don't do something like that. I hate to go into lecture mode, but it's what I default to with this. And I know I'm getting to that point where people's eyes can glaze over. So even when I edit this, I'll have to even evaluate whether I want to leave that statement in or not. It's true. People are the whole problem. You choose to be an administrator, and of course most people don't even know better because the system doesn't tell you better. And you choose to go browse the internet, and you choose to read your email, and you choose to do those all things. There is no security. So they're trying to get you to do something. I think it's more for show than anything else, to be honest with you. I think they're more interested in the fact that they don't want the thing to run slowly, as I said earlier. And that's why they have the bar a little bit higher than they should today. Most people that have a computer that is probably almost all, Gen, 7th Gen, definitely all 8 and 9 and above Gen. What you have, and I didn't put a graphic on here, but they actually have in the CPU a portion of the CPU set aside to emulate that chip and to emulate it in a way that is very similar to a TPM. They have that built onto the CPU. It actually completely emulates the TPM type functionality. It actually can store the keys on the CPU chip. I don't know how tamper resistant, though, they would be. That's yet to be seen. So it's not necessarily a level of protection that a separate TPM module would provide. Here's an example of a TPM module. As a matter of fact, I have a motherboard here that I wanted to show you, the socket. And this is a PC that I've been playing with. I'm not exactly sure what I'm going to use it for. I had enough spare parts that I decided to get a motherboard, and basically everything on this motherboard is spare parts. I have a spare CPU, an i3 8100, so it's 8th gen. I got 8 gig of memory here. I've got an M2 drive that's small. I think it's only like a 256 gig. But right here, and this part of the motherboard here, is the front panel connector. This is the one that I showed in my short. And right next to it is the TPM socket. Again, it's not needed because that particular CPU would support it as a firmware-based TPM. That's it for what I wanted to cover here. But if you do want a copy of this presentation, I've created a separate email that I have listed in the bottom of the slide here, pefordoers.request@gmail.com. If you want to send me a request to that, if you want one, I have no problem sharing it. I'll send it to you in PowerPoint. You can run some of the freeware PowerPoint readers on it if you're interested. Well, that concludes this video on computer and information security. What'd you think? I've spent some depth in some areas, some of which is what I call going into the weeds, but it had to be done, really. Now, it was a long video here, but it's a full-blown lesson. So if there's enough interest in it, as I said earlier, I might turn this into a series, and I could cover even some of those topics, even in a lot more depth, if you are interested. But there's many more topics that I'd like to cover as well. And if you're interested in ever trying to become a CISSP, a Certified Information Systems Security Professional, I've been one for like 20 years, then a lot of material I covered here is directly applicable to the exam that you'd have to pass. But there are more domains, more topics to be covered. So it's something to consider in future lessons, but again, only if there's enough interest. So again, hopefully you liked this video and you got something out of it. And if you did, give me a thumbs up and at least consider subscribing to my channel. Well, until the next time, take care. Stay safe, and please, even though things are winding down in the world, still try to keep healthy, okay?